No. Does anyone have any questions from homework stuff, or general questions, or questions from the practice quiz? Or does anyone have any answers? I never really asked that. Or statements, or I already briefly discussed earlier the historical significance of the day, so I'm not going to say much more than that. Though I feel I should probably, but if you're not sure why today is historically significant, I don't want to say anything I was about to say pay more attention, but
it's Hitler's birthday.
Oh God. Okay. True. And of course, we decided to also signify the day in celebration of cannabis, which is something that we knew Hitler probably.
That's what I was going to say. I just thought it would be a little inappropriate.
Oh, so you went for Hitler.
Right, so you went with Hitler.
Yes, sir.
This is a remarkably exciting conversation already. Everybody's like, oh, thank God, man. We're talking about something interesting instead of, pre-calc. Yes, those are both true. Today is a celebration of marijuana. It's also, and the, what do you call it? The theory behind that is because it's related to some police officer number code stuff, which is completely false. I don't know if anybody knows the reality of it. Anyway, enough about marijuana, probably. It's also Hitler's birthday, which is not why I brought it up. But there's something that happened today, this year, that will make it going forward historically significant. So if you're not sure what that is, just open anything. Look at any news source anywhere in the universe and you will quickly find out. So anyway, any questions from practice quiz, homework? We have the quiz tomorrow, right? So any questions, let me know. Or questions from chapter 9, more recent stuff. What is the quiz on tomorrow?
Chapter 8.
Yes. Oh, this quiz will be due, I don't know. It's not going to be due. Yeah, if it's due to, I'm going to make it due Friday morning. I think I've done that before. That's what I normally do if it ends on if it's on a Wednesday when it's given. Yeah. Okay, I'm a little concerned when no one has a question and there are such weird ass problems in the homework. I don't know if you think that I don't think they're weird, but I know all too well that they're weird, which is why normally it's best when there's a conversation that happens. But if you're all good, if you didn't notice, the solutions video for the practice quiz is up. I also just now unlocked the module that I didn't mean to still have locked, so that you can turn in your chapter 9 homework that you're all working on and just waiting until I did that so you can turn it in. So you can do that now. Okay. And if you weren't here yesterday, you missed something. I mean, I don't know what kind of adjective people would use for it that were here. I'm sure there would be some choice ones. But at least it was something you just had to spectate for most of it, right? You just had to watch it happen. Hopefully most of you kind of follow it, see if you understood where things were coming from, and we proved several things. So let's take a minute. Let me show you, in case you weren't here yesterday and you don't know this is up here. Let me show you something really nifty. Let's see. So let me become a student for a minute. So you've got the hold on. You've got the practice quiz 7 solutions video is there. There's a practice quiz 7 if you want to go to that first. This is the sum different. What did I put up here? I already forgot what I put up here. Did I just put up? Oh, this is the thing that's totally not written on. I think I still have to post the thing, but I was going to post up there a more finalized version. But you've got the video from yesterday if you want to go see it being developed. So what we did yesterday was this. We proved these identities. Hold on, let me identify them. Let me identify the identities. That was funny, Jeff. Be quiet. All right, so. All right, so most of this should look old. Let me point out a couple things real quick. This is still in our future. This is still in our future. Cool? This is future stuff. What looks interesting here? Just to point something out real quick that I pointed out yesterday to somebody. The thing I just underlined. What is that? That piece of it.
Pythagorean theorem.
Pythagorean theorem. So what this, and so it's like Pythagorean theorem with a little extra stuff on it, right? So what this really is, what all of these really are, is Pythagorean theorem, what it looks like in a non-right triangle. Sweet. So that's in our future. Then we have this weird little law of sines, right? I like it. I'm going to avoid making stupid jokes about what happens if I break it. All right. What we actually proved yesterday was these. Does anyone remember a personality trait that I let you know about cosine from yesterday?
He's an asshole.
Yes, cosine is an asshole. I like it. If you are easily offended, then I probably just offended you, and I've probably done it multiple times every class, and it's amazing you're still here. I'm not going to point that out. Well, maybe I will. Screw it. I'm not going to point. So the idea of cosine being an asshole actually carries through a lot of different things. It's really neat. But we'll see. All right. Even into calculus. I'm just pointing out a few. So this is what we did yesterday. We proved these yesterday. And then the minute we prove those, we basically immediately prove these. Because, for example, this is just sine of theta plus theta. So I can just use this and put theta in place of both and end up with this. Are you guys all with me? Again, if you were here yesterday, you saw that happen, but it's kind of nice to remember what the hell we did. And here's another example of cosine being an asshole. Look at sine. Oh, let me give you one option. So, and cosine's like, ha, 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 pick one. Good luck. It's like, oh shit, cosine. Sorry, I'm sorry. I might be overselling that, but I still like it. So what I want to immediately do is I want to prove these half angle identities. And then I want to do some actual verifying identities. I've got hopefully a very useful handout to have sitting next to you as you verify all kinds of identities. I need you to understand right now, verifying trigonometric identities is a huge part of pre-calculus, a big part. Do you understand? I'm not saying it's going to be like the next 3 weeks. I'm saying it is a really important part of this course, right? And the better you kind of get at playing around with these identities, the easier you're going to have some parts of calculus where there's a lot of trig. That'll be a little easier for you. And if you go further than that, holy shit, trig becomes so huge. It's insane. So the better you are, anyway, I think I've solved that. So let's prove these. And let me just point out real quick while I'm here. This is some old stuff about inverse stuff, right? We talked about the domains and the range. So I kind of put it on there just for 2 reasons, just so you have a really quick reference and to make the point. I'm going to clear all this away. That is something you have to memorize because it's above the black line. right? Where you must memorize everything above the dark black line, right? So where's my smart asses? So I have to memorize trig laws, which to memorize? No, be quiet. What's on the sheet, right? These are all trig identities, but they're not as often used. And like I said, they're actually ones I don't have memorized. I'm not going to make you memorize anything that I don't have memorized, right? I'm going to be better than my PE teacher. I don't know if you've ever had a PE teacher that made you do several sit-ups. I'm like, you couldn't even do one, my friend. So I want to be better than that as a math teacher. Okay. So let's do this. Let's prove those half angle identities. I've got some double angle. We got double angle identities. Let me turn off my Bryce Canyon behind me. Hold on. Bye, Bryce Canyon. I took this photograph, by the way. This is my photograph. Nah, 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 nah. All right, let me see. Bam. Yeah, let me move you guys over here. Let me move this over there. Well, let's see. How do I want to put this together? It doesn't matter, Jeff. Okay. All right, so. If we start with, all right, one thing I really want to, now just bear with me here for a minute. Some of you guys have already gotten this down pretty pat. So here's sine. In fact, that's right, I want to do something with this. Somebody remind me, what's sine of 2 theta? Again, what's the identity?
2 sine theta times cosine theta.
Big gas. So somebody help me out. This is going to be silly for a minute, but I don't give a shit. What then must sine of 2 alpha? Somebody else. What's sine of 2 alpha?
Two sine alpha times cosine alpha.
Right? I told you it was going to be silly. So, all right, here's one. What's sine of 2 theta? Somebody else. Is that freaking you out? Sine of twice this is 2 sine this. Twice of sine of twice this is 2 sine this. Sine of twice this is, you can do it.
4.
2 sine 2 theta cosine 2 theta.
Yes. Okay, good. Now I was really nice right now, because normally if I put this down here, maybe I should have done this anyway, but I don't know, I'm trying to be nice this semester. Normally, if I put this down here, I immediately have somebody tell me it's this, which is unbelievable amounts of bullshit. This is unbelievable amounts of bullshit. You need to have a connection with what parts of the formula relate to what other parts of the formula, right? This is not a 2 because this is a 2. So what is sine of 4 theta then? Isn't that sine of 4 theta? Isn't that just a weird way to write sine of 4 theta? Yes? And it's actually this, isn't it? It's not 4 sine. That's bullshit. That's complete bullshit. All right. Let me push this point just a little bit further. Get out of here. The reason this is because this is sine of theta plus theta. That's what this is based on. Right? All right. So if I have sine of 4 theta, I have to figure out, okay, that is sine of 2 theta plus 2 theta. Okay, now that matches with that, which tells me that's going to be 2 sine 2 theta cosine 2 theta. I like it. But do you understand? You can understand why somebody would think sine of 4 theta would be 4 sine theta cosine theta, because they're not remembering the connection about what's important, what tells me what goes where. Are you guys following me at all? So it's a really easy mistake to make. And when a student makes that kind of mistake, it tells me, oh, you forgot the connection between what the formula is and where it came from. So, all right. I'm not quite ready for the half angle yet. What can I do with this? Could I do anything with this? There's a couple things I could do with this.
Make it 2 theta.
You mean like erase the 3 and make it 2 because it's a better problem?
Yeah.
What do you mean, make it
No, I mean, like factor it.
Oh, I see. So isn't the sine of twice like that, you mean, right? Right? Yes? Yes, maybe?
No, I was gonna make a 2 theta in parentheses. The other way.
What you need, what you always need to be able to use this is you need to have sine of twice something. You can't escape. To be able to use this, I need sine of twice something. That's what this requires to be used.
Is it a form of multiplicity or is it addition? Because it was, you were using, it was theta plus theta, right?
Yes.
So is this not 2 theta plus 1 theta to make 3 theta?
Oh, that's the other way to do this. But that's not going to quite work the same way. All right. I really want you guys with me. So here's one way to do this. And this would lead to 2 sine 3 theta over 2 cosine 3 theta over 2, which is kind of gross. Stay with me now. Or I could not use this. If you choose, all right, really stay with me. If you choose to write this like this, can I use this? No, not yet. I have to use sine alpha plus beta. I have to use the addition formula, right? Remember, sine's nice. What does that mean? Sine's like, well, cosine, come on, let's take turns, cosine. Okay. So sine theta cosine 2 theta plus sine 2 theta cosine 2 theta. Get out of there, 2 theta. Stupid asshole, cosine messed me up. Sorry. That's the nice thing. I can just blame it on cosine when I make a mistake. Let me stop for a minute. I really want you guys with me on this. This is if I can and want to rewrite the inside as twice something. If I don't want to rewrite the inside as twice something, I can actually just go back and use. Now does anyone see what I can do here? What's this? Look, can I rewrite this? Yeah, I got right. You guys, can I rewrite this? Yeah, I got 3 choices for that, so I can kind of pick the best one. It depends on what I'm going to do next. Okay, I just want to show you a little flexibility with how these work. Well, first off, what this needs to work. Do you always have to do it that way, or is there another way? Yes, you don't have to use this if you don't want to. You can use what this is based on. You can use the addition formula to maybe do something different. Okay, so there I would keep going here. Okay, good. All right. Now, I haven't really given, well, all right, let's do this. Let's do some, what do I want to call it? Gaining trust in this. Let's gain trust. I don't know. Let's gain some trust. What the shit does that mean, Jeff? I don't know. Just go with it. So watch this. If I have sine of, what do you got, Jeff? You can do it, buddy. Sine of pi, let's say, trying to come up with a decent. All right, yeah. Sine of 3 pi. We should know what that is already. But isn't this, yes, but isn't this, now just to show that this works. So whatever I get, if I use this rule, I better still get 0 at the end. So isn't this equal to sine of twice 3 pi over 2? Are you guys with me? And again, I really want you to understand. This is not meant to be where this makes things easier. I'm kind of doing this backwards. I'm saying, do I even think this is true? Let's see if this is true. Let's plug some shit in and see if this thing does what it's supposed to do, right? So that's what I'm going to do. Let's plug some shit in. Let's make sure that this works. If it doesn't work, let's throw the damn thing out. Let's call up Math Society and say, hey, Math Society, that's bullshit. Did you know that? Oh, okay, throw it out. All right. But it's not bullshit, so it's too bad. So what would this become? This would become twice sine of
3 pi over 2.
pi over 2 cosine of 3 pi over 2. And so this is, sure enough, this is twice -1. I should have asked you what that was, damn it. And what's this? What's cosine of 3 pi over 2?
0.
Good, 0. No, so it is 0 the way it's supposed to be. So again, this was not a better way to figure out sine of 3 pi. This was just making sure this identity actually works in some situations. That's all this was. Right. Okay. So you could actually pick any, let's do one more before I drive you insane. I'm gonna erase this. So what about sine of twice 3 pi over 4? Which would be sine of 3 pi over 2, right? So we already know what the answer should be. So sine of twice theta is 2 sine theta cosine theta. What is sine of 3 pi over 4?
Over 2, which is
About
1.
2 over 2. I like it. And what's cosine of 3 pi over 4?
Minus rad 2 over 2.
Good. So those cancel each other out. What's rad 2 times rad 2?
2.
2. I like it. Half of 2 times half of 2 makes a whole 2. So this will be -2 over 2, which is -1, which is what frickin' sine of 3 pi over 2 is supposed to be. Yay. Okay. Again, this is not a use of this. I didn't just use this. I didn't prove it, but I got a feel for if it works or not. It seems to work. Okay. So that was gaining trust. All right, get out of here. Now, this is pretty, all right, I'm not sure how to describe this. This doesn't happen very often that we don't know twice the angle. Give me an angle that we know the values for. Anybody, give me any angle that we know the values for. Anything.
Pi over 2.
Pi over 2. Do you know what twice pi over 2? Do you know the angles? Do you know the trig functions of twice pi over 2?
Yeah.
Of course you do. What about 30 degrees, just to go to degrees? You're supposed to know the trig values for 30, or pi over 6, if you like that better. Do you know the trig values for twice that? Of course you do. It's just freaking 60 degrees. Of course I know the trig value. So it's kind of, we're going to develop the half angle formula, which is a little more interesting. Because do you know the trig values for half of 30 degrees? Oh, hell no, right? We don't know 15 degrees. I don't know what the cosine of 15 is. Are you kidding me? So, let me write down, what is cosine of twice theta? What are the options for that?
Sine squared theta. No, 2 sine squared.
Yeah, 2 sine squared. What? So, no. Come on.
1 minus 2 sine squared.
There it is. So where I always start is this one. I'll tell you this. I have this one memorized. I like this because it's kind of like the opposite of Pythagorean. Cosine is an asshole, so he pushed himself to the front. But it's up to you to figure out how you want to memorize this. Why do I remember this? Because then, when you said sine squared, Rio, I didn't immediately know if that was supposed to be first or last. So you'll see what I mean in a minute, because they don't have that memorized. I have this memorized. And then, isn't cosine 1 minus sine squared? Minus another sine squared? Oh shit, there you go. Or isn't sine squared 1 minus cosine squared? And the negative turns that around, so that becomes 2 cosine squared minus 1. So there's the 3. I have this one memorized, and then I make these when I need them. Just to save some space in the old brain. I'm running out of that, right? Okay. I like it. So now watch this. This is kind of cool. Let's focus on this for a minute. Okay. So if cosine of twice theta is 1 minus 2 sine squared theta, what is cosine of theta then? I don't know. Let's see if you guys... All right, this is weird. This is too weird, maybe. What is cosine of twice theta over 2? Is that better, guys? You guys, it's sort of like if I would have said, what's cosine of twice beta? Wouldn't that just be 1 minus 2 sine squared beta, right? You guys... You guys with me? So if cosine of twice an angle is 1 minus 2 sine squared of the angle, what is cosine of twice this?
It's 1 minus 2 sine squared, or sorry, yeah, 2 sine squared theta over 2.
I like it. Now, can we solve for sine theta over 2? So I'll know what the sine of half an angle is. Do you understand what I'm saying, everybody? This is a neat, this is sort of like what you were doing earlier, Jordan, but this is kind of like pushing that even. We're saying, let's change the inputs. So if I change the input from theta to theta over 2, isn't this cosine theta? Yes? And this is theta over 2. So can't I solve this for sine of theta over 2? So then, for example, if I want to know what the sine of 15 degrees is, that's going to be related to the cosine of 30 degrees, which I know. You guys follow it all? This is so cool. Probably not doing this in the coolest way, and I don't give a shit. This is cool on its own. So let me write this a little better. Let me erase this here. We'll come back to this guy later. Okay, come here. Let me take my other marker. So let me write down what I got. I got cosine theta equals 1 minus twice sine squared theta over 2. All right. How do you solve that for sine? Let's first solve for sine squared. How do I solve it for sine squared? What do I do? You guys, what's up? What's happening? Yeah, all right. What's going on? So if I had this, how would I solve for x squared? If I had this, is this easier to look at? How do I solve for x squared? Are you?
Square root.
No. Eventually, yeah.
Get by itself.
But I see if I do that first, that sucks so bad. That sucks on so many levels. So I need to, that's why I said solve for sine squared first, because then I can square root it directly. It doesn't have any other shit around it that I have to take into account. All right. So if I want to isolate this, I'm just going to do it. Holy shit, -1. Was that hard? Come on. Sorry, I got to get a little angry at you guys. There. I don't know what's happening. Is it just because there's other shit going on? How do I solve for this? I'm going to divide, but I'm going to first move the 1 over. We all know how to solve equations. We know how to. And don't forget, the thing I just did over here, you can see is cosine, and let me call sine squared x squared. Let me just do that. I mean, there, as long as you remember what the shit these things are, this is perfectly valid. And I was hoping that somebody would tell me this. Of course you do that first. All right. We'll let it go, John. Now, of course, what do I do next?
Divide by 2.
Yeah, divided by -2. Right. All right. So now I've got, let me take this out of here. Let me bring him over here. Sine squared. And let me do this one little thing. We don't like these negatives on the bottom, so I'm going to take the negative up top, and it's going to turn these around. Is that cool? I'm going to change the signs of the things up top. I didn't do anything weird just now. Is that cool? Take the negative up top, apply it, change the signs. Now what's the last thing I can do? Now that I got this thing by itself?
Square. Or root.
The mini, right. So this will be sine of half an angle is equal to plus or minus square root of 1 minus cosine of the full angle. Or, let me see if you guys can handle this. All right. All right, so this is the way it's written on the sheet that's in Canvas. Wait, I'm sorry. Let me catch up with the chat somebody sent me. The number of all these one okay. How do all right, let me focus on that in a minute, because that's a good point. I want to make a general point about that person that just sent me a chat. So this, you can see it on that sheet that I put up on Canvas, correct? We just proved it together. Is there a better way to write this? Yes. I really want you guys to see this. Whatever this is, all right, let's do an example. Let's do a concrete example. How can I do the sine of 15 degrees that I keep bringing up? If I put a 15 here, and how do I tell which one of these I'm going to use? Well, you know, what's the sine of 15 degrees? What's it supposed to be?
Positive.
Positive. So that's, you pick this based on where the hell that thing is. Does that make sense? So we have to pick this based on which quadrant my angle is in. And of course, with trig function, right? Where it's positive, where it's negative. Okay, I like it. So I'm going to pick the positive root. Can somebody please tell me what's going to go in here?
30.
Yes. So immediately, so is everybody with me? Is everybody with Jordan? Because this is half the angle, so that must be the full angle. That's 15, that must be 30. So what's a slightly better way to write this funky ass thing? I shouldn't yell so much. I might have a window open. Little people live next door. I gotta be careful. All right. If I write sine theta instead of theta over 2, what has to show up here to maintain what the formula is trying to show?
2 theta.
2 theta. That is actually a slightly preferred way. Maybe it's just me, I don't know. But either way works fine. They both mean the same thing, because this part of the formula is just showing the relationship between the angles. And they both show the exact same relationship. This one is twice that one. This one is twice that one. So they're the same formula. Okay. Let's actually, can you guys do that? Do it. Figure out what that is. It's gonna be funky. can't remember. Let me think. I can't remember. It sucks. Oh, it's too bad for you, Jeff. So sine of 15.
Do you want like the decimal?
No,
Okay.
I mean, no, thank you. So I definitely don't want the decimal because I could have just put sine is 15 in my calculator from the beginning. So what is the cosine of 30 degrees?
Root 3/2.
Right, 3/2. Let me simplify this a bit. Couldn't I multiply top and bottom of the inside by 2 to kill this fraction, right? Get out of there. And the bottom, so okay, I really want you guys with me what's happening. We don't like fractions inside of fractions. We don't like the fracception shit because the movie I have to watch again with the notebook. I don't like this inception business. So let's kill one of those fractions. Let's wake some of these people up. That goes there, that kills that. So I'm here, and then what's the square root of 4? Because that's what the bottom is, right? Square root of 4 is 2. So there you go. That's the exact value for the sine of 15 degrees. Now, most of you are probably not as excited as me that we can get an exact value, but I want you to understand this is a huge achievement for us humans, right? Back in the day when we didn't have any calculators, and some of you guys are like, do you know what century it is, Mr. Waller? Be quiet. All right. And by the way, somebody was asking, anyway, we are just barely scratching the surface of the usefulness of these identities. So even if you're like, well, that's bullshit, I can just put them in my calculator and then the decimal's fine. I understand, but this is not the only reason we have these. And this is the immediate way to get used to what these are saying. Okay. Now this is kind of neat because it's a nested radical, right? Isn't that neat? Okay. And there is a way to break that up. And I kind of have to remember how to do that. It's been a while since I did that. So I'll try to figure it out for next time. Okay, so we just have to prove the other one for cosine. So I come back to this. So I got to remember now. Okay, so now if I do the exact same thing we just did, but I start here instead of 1 minus twice sine squared, right? How did we get to the formula we just used? I started with cosine 2 theta equals 1 minus twice sine squared. So now I'm going to start with this, and I can solve for this guy. So first let me change these. So I'm going to change that to cosine theta equals twice cosine squared theta over 2 minus 1. Let me add 1. We divide by 2. And then I can finally take a square root. So I get cosine of theta over 2 equals plus or minus square root of cosine theta plus 1 over 2. That's the way it looks on the, what do you call it? Green sheet, right? Trig law sheet up on the canvas. Oh, good question, Amanda. Yeah, the double square root basically has to be fine for right now. In fact, there's a really neat yeah, don't think about this too, and it just keeps going forever. So you have infinite nested, yeah, exactly. Oh no. Yeah, so I'm not gonna, let's not think about that. So 2 is fine. There is a way to break that up a bit, I just have to remember, oh, that's how you do it. Is that how you do it? I think I figured it out. Okay, maybe. All right. Let me give you guys a problem to try, and I'll see if what I just thought of works. Why did you erase it, Jeff? That was really dumb. Hold on. All right, let's see if that works. I think that's gonna work. Maybe. I don't know anymore. Shit. All right. So here, I want you guys to figure out what is the cosine of, what do you got, Jeff? Let's do, yeah, I like it. So what is that going to be? Let me make sure I get this right. 112.5 degrees. Oh, I love it. That is so exceptionally yummy. All right, so you should be able to figure out what this is using this. And I just want to point out, be careful about your choice of this. Let me see. I don't think, no, this can't be right, Jeff. No, damn it, that's not gonna work. I've done this before. I can't remember. Damn. Shoot, just no. So that very quickly didn't work. That's all right, Jeff. It's okay. What is twice this?
125.
225, right? Is that an angle related to something you should know?
Yeah.
Because how far away from 180 is it?
45.
45. So then this should work, right? So if that's 112.5, then that has to be, okay, so keep going. Oh, that can't be right. Oh, that's gross, Jeff. I don't know. Oh, barr. All right, let me catch up to you guys. So this will be, so what sign am I going to pick?
Negative.
Yes, because the question is this. I am in the which quadrant?
The second.
Second quadrant. Yeah, I didn't mean which. Sorry. I'm in which quadrant? I'm in the second quadrant. 112.5 is going to be like right there, maybe. So I know cosine is negative. Do you understand? It has nothing to do with anything else. You know what quadrant that angle's in. So therefore, you should be able to figure out which sign this thing has. That's why there's a plus or minus there. You got to figure that out. No special ambiguity or nothing amazing, no incantations. All right, I'm stuck on the which thing. Square root, cosine of twice this. So 225 plus 1 divided by 2. And what is cosine of 225? 45-degree reference angle. It's in the third quadrant, right? You can do it. What's cosine of a 45-degree angle?
Minus.
Yes, negative because it's in the third quadrant. I like it.
Root 2 over.
Yeah, and I just want to make sure everybody's with me. This angle itself is in the third quadrant, so cosine is negative. And of course, every 45-degree sine and cosine are rad 2 over 2. So now I can do a little bit of cleanup like we did before. The bottom is, so I'm going to multiply top and bottom by 2. So the square root of 4 is 2. And on the top, I'm going to get left with 2 minus rad 2. Wow. And that's a neat looking thingamajig. So hopefully you understand. I mean, this is actually red connection. I'm not sure what that means. This is hopefully you realize this is better than you might think it would have been. If I would have told you cosine of 112.5, let's solve that by hand, you would have probably thought you get a worse answer than this. I would think, because 112.5 degrees, that's weird as shit. You guys doing okay out there, everybody? All right, and let me quickly show you, real quick, how to double check this in the calculator. See if this is right. Okay, hold on. Oh, let's see. There you are, calculator, come here. Oh, robotic. Oh, I see, I got a bad connection. Did my connection get bad? All right. I did have internet connection
Me too.
earlier. Jordan, you kind of froze for me for a minute, so it might be on your end. So again, is everybody good up to here? Somebody was asking me a question about how I got here. So the next thing I did was I multiplied top and bottom by 2 so I could kill this. So I don't have a fraction inside of a fraction. It's just standard convention to not do that. Does that make more sense? Person that private messaged me, so I don't want to call you out. Okay. So let's take a look here. So first thing I do is make sure I'm in degrees. I'm not, right? So let me go do that so I don't get all angry later. Okay. And I learned that the hard way, so learn from Jeff. So the first thing I do is just figure out what the hell cosine of 112.5 is, and that's when I get people out there saying, well, we could have just done that from the beginning, asshole. Like, shut up. So now I know it's supposed to be negative 0.38, blah, 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 blah. So let's see what this is. So negative square root of 2 minus square root of 2 over divided by 2. Thank God. That's always a tense moment for me. I'm like, I could have made one stupid mistake. But no, yay, it's the same thing, yay. So you can always double check your answer. All right. Okay, all right. And believe it or not, there are areas where this, does that look like a really good answer, guys? Does that look like all right, how do I want to say this? Not pretty. Does it look like it's pretty accurate? I mean, just tell me, does it look accurate? Does it look like it's pretty accurate to most humans?
Yeah, I guess it goes really small, so it's got to be close, right?
Yeah. Now, of course, how long does this go? How long does it actually go? Because the calculator doesn't show me all the digits.
Probably indefinitely.
Yeah, infinitely, because it's based on square roots and numbers that can't take square roots up. So this is an infinitely long decimal chain. And for a lot of applications, if you stop at this decimal place, you could get very off results. For example, you're talking about space between atoms, right? And this is a crucial measurement you're going to take so you can figure out how to set something. You're going to be off by crazy amounts. So that's why we need to have a way to get the precise exact thing. And then I gotta have some supercomputer take this thing out to the whatever decimal place I need. Does that? I know you're not going to do that. We're not going to do that this semester. We aren't. I'm sorry. We're not going to build our own power supplies and our own little containment center, containment unit, and put rubidium atoms in there and have them float around and do all this magnetic field shit. I'm sorry. We're not going to do that. I'm sorry. But if somebody did have to do that, they would need, that is bullshit. They would look at that and go, holy shit, you rounded the hell out of that thing. And most people would be like, what are you talking about? That's a lot of decimal places. Anyway, sorry. Enough of that. Okay. So it's nice to remember, you can always, there's a way to check what you just did. Of course there is. For most things, I gotta be careful. All right, so those are the half angle formulas. So I think the last thing I wanna do today, which sounds like class is almost over and it really isn't, is look at some example problems. Let me show you this, okay. I gotta figure out what order do I wanna do this in. All right, I want to do it in this order, I think. Okay. Get out of here. Go away. Okay, thank you. Let me pull this up real quick and then I'll show you some idea of what you're going to have to do. All right, let me make sure this is okay. Sorry guys. Let me make this active. So if you go to Canvas, by the time I finish saying this, bam, there we go. If you go to Canvas right now, under Unit 9 module, you will find something called Trig Identity Practice. Not Twig identification practice. So this is not a course about trees all of a sudden. This is still, okay. Stupid joke, I don't care. Everybody got that handout? Doesn't it look just yummy, right? Isn't that a creepy and probably widely disputed claim I just made? All right, so let me open this up a better way. Can you guys just look at the first problem and think about what you could do to verify that identity? Who remembers the one thing about if I'm trying to verify that the equation is true, what is something I've told you guys you're not allowed to do? What can you not do? If you're trying to verify that the equality is true, what is it you're not allowed to do?
You can't treat it like an equation.
Yes, which means you can't do something to both sides. But each side is an expression that you can simplify the shit out of. You can rewrite it. So if you take one side and work with it, and maybe take the other side and work with it, you want to try to make both sides end up being the same. You want them to meet somewhere. That would prove that one side does become the other side, and that proves the equality. All right, let me see. Hold on. Let me find this sheet. Trig Identity Practice. Where are you? Over here. All right, let's see. Trig. Scheisse. Of course I didn't call it that. You crazy person. All right. What else would it be? Let's see. Oh, map. It was okay. I understand now. Are you guys working on that problem? Here we go. Here it is. There it is. Even better. Kick ass. All right, let me pull this thing up here. All right, guys. So we're looking at this one right here. This is what I told you before. This is, I understand. People don't want to hear this. They're not as excited about what I'm about to say. But this is the math class where you really, really have to start playing. You have to start playing around. And I don't mean doodle shit. I'm going to doodle some shit. I mean, play around with the math. So this is entirely possible. You'll do a bunch of work and it all was wrong. You should have started on the other side. You should have used a different identity. That doesn't mean you did something wrong. That is a part of the process, right? I know math really well. I will do a problem and I will pick the wrong thing and I will go, well, that's a dead end, and I will back up and I'll try it again. I don't care how good you are at this. You're going to pick the wrong thing sometimes. Don't tell me what the answer is, or don't start telling me what to do. But does anyone think they have this first one figured out?
Yes.
Okay, so hold on to that for a minute. There's a very simple way to do this first problem. All right. Can someone, Rio, I think you've got the right answer probably. Can somebody else who's not sure exactly what to do, what are you trying to do? What are you considering doing? Or is anyone completely lost and needs me to kind of go over what you're trying to do? Just be honest. You got the private chat option. If you want to send me a chat saying, I don't have a flipping clue what the shit we're doing, dude. Anybody want to send me that? No?
So
This-
secant is 1
Yeah.
over cosine. So can't you just flip?
Oh, okay. All right. So you're looking at this side, right?
Yes.
Okay. So you noticed what exactly? Say it again. Secant.
So secant is 1 over cosine.
I like it. And what's
So
tangent?
it's 1. What did I write down? 1 over cotangent.
Okay. But then you can't really, you're not connected then, and you wouldn't be able to do anything.
Sine over cosine.
Yes. Do you see how that's tangent
Yep.
sine over cosine? And that actually leads you to, and again, if somebody else had a different way to do this, don't worry. Stick with the first thing you see. Don't try to do it the best way, right? So there is a slightly better way to do this, but it's actually not that far off from what you're doing. Because now what can you do? What was the whole idea up here when it had fractions inside of fractions? I don't want that. I want to kill them. So how do I kill these fractions here on the bottom?
Multiply them by the bottom.
Yeah, multiply these by cosine, which means I also have to, at the same time, to make it legal,
Do it to the top.
do it to the top. All right, let me stop for a minute. And again, if you didn't see this, or if you did this a different way, and you got the answer, then, I mean, this is not the only way. Definitely not, right? But
I
this will
started
get you there.
splitting the first part in half in a similar way.
Okay. So let me do this real quick. So that will cancel out with that. You'll get cosine squared over 1 minus sine, which is exactly what it's supposed to be. Check, done. Now, who had a different way to do it? What did you do, Austin?
I got the cosine squared x to equal cosine x and was trying to figure out if I could get the bottom to look the same as well.
All right, so that's kind of like the way I would look. Now watch this. That's kind of like the way, oh, Jeff, what are you doing, dude? Get this out of here. Sorry, I'm using the wrong thingamajig. That's the way I would look at this. And listen, please, dear God, the way I would look at something is very often not the best way. So I want you to realize that. But I'm just telling you, this is the way that I thought about it when I saw this problem. That's all that means. Doesn't mean it's better or worse or anything. How do I make cosine squared become cosine? What do I have to do? So starting with this side.
Take the root.
No, see that? I can't take the square root of the top and bottom of a fraction and maintain equality. So what's another way? If I have cosine squared, I can just do what to have a cosine left?
1 minus sine
take it.
squared.
Well, cosine squared is 1 minus sine squared, but you see that's taking me further away from what I want it to be. Can't I just divide it? And I can also divide the bottom by. Do you see how that's the exact opposite of this? They're the same thing. This one, you gave this side a cosine. This way, I'm taking a cosine away. So of course, they're still going to end up meeting in the middle. I really want you guys to understand that. So then I end up with cosine x. And this will be 1 divided by cosine, which is secant, minus sine divided by cosine, which is tangent, which is that. Check. Please, dear God, please let me know if I have lost you somewhere, please. So what is it that's guiding me on these problems? I am constantly keeping an eye on the other side of the equation. Which side do I start with? Normally it's the side that I see something I can do. But let me see, like this problem, part C, which side am I going to start with?
Yes.
I'm going to start with this side because it's got stuff I could do. This is just tangent. There's really not much I could do except write it as sine over cosine. Do you understand what I'm saying? So sometimes there's one side where there's stuff I can simplify, so I'm going to start with that side. Sometimes, like part A and part B, it looks like I don't care which, I can start with either side. Just start doing stuff. So what kind of guided us on this first one was kind of like that thing I told you guys last time. I want a cosine up here. So I can divide this by a cosine. I got to divide the bottom by a cosine. And I know it's got to work because if I do that, the top becomes what it's supposed to be. Or looking at it like Charles, this guy just needs another cosine. I mean, multiply, and I got to do the same thing to the bottom. And I got some faith because I know the top's going to be right. So the bottom has got to work out. It has to. Are you guys with me? Because when I say this, that means it is true. That means it works, which is kind of nice. It means it's going to have to work. As long as what you do is legal, it eventually has to work. Okay. Get this out of here. So what about this guy? There is something else we discussed. This one, well, to be honest, it doesn't matter which side you start with, but there's a few different ways to do this.
I first made the first part 1 over secant x.
And how do you mean you made the first part 1 over, oh, so you didn't just do that, you fully broke the first side up. Is that what you're saying?
Yeah.
Okay. So let's go down that road. Let's see. So you did 1 over secant x plus secant x over secant x is 1, right?
Yeah.
Does everybody follow? So she started with this side, and she just went ahead and divided both parts by secant. Okay. I am not sure where that's going to go. Did you see where that might go next?
I immediately moved on to the right side.
This is a beautiful example. This is beautiful. So, I mean, that's kind of nice. You go, let me do that. And then you look at it and you go, that doesn't look any more like, okay. So, I mean, this is a perfect example of, okay, then I wasn't supposed to do that. Not, okay, I don't understand this at all. Not, okay, I don't know math. Not, okay, I suck. None of that shit. It's, oh, okay, I got that step out. I mean, it's part of the process. So you guys see what I'm trying to tell you? Because I know the pain of these. I know it. But I also know the joy, obviously, because I love the shit out of these things, which I know is weird. Anybody else? Somebody else have a different suggestion on something we could do in part B? Tell me this. What would you do with this problem? How would you simplify that? We talked about this the other day.
Multiply by
The conjugate?
Yeah, the conjugate. I love it.
The conjugate.
Right? Because then when you square these, because you multiply them by themselves, they become not irrational anymore. Now, something similar but different, which I love that phrase, happens here. Couldn't I multiply top and bottom by 1 minus cosine? Or not, I'm sorry, not 1 minus cosine. What should it be? I said that wrong. 1,
1 plus cosine x?
yes. Now, to be honest, I've been not thinking about this on purpose. I came up with something to try, and then I stopped thinking about it. I haven't even done the next step in my head yet. Do you understand what I'm saying? I'm trying to keep this. I want to go down the road with you. So this is something that just came to mind. There was something else I noticed that I might try if this doesn't work, but let's see what happens. So what happens on the bottom?
1 minus cosine x.
No. 1 times 1 is 1. The middle
Oh,
term's
cosine
cancel.
squared.
Cosine squared, yeah. And what's nice about that? I'm not even going to look at the top yet. What is 1 minus cosine squared? What's sine squared plus cosine squared?
1.
1. So what's 1 minus cosine squared?
Sine squared.
Sine squared. So now look at the top. Look at the top. This is going to happen not every time, not half the time. I don't know, sometimes. But do you see how I don't want to multiply that through? Because what's it going to do? It's about to die, right? Do you guys see that? It's about to die. Oh, let me see. That's interesting, Jeff. Oh, that's neat. Is this correct then, Jeff? Did you? Oh yeah, I did. That's right. Now let's bring back Jordan's first step. I love it. All right, I was just freaking myself out because I'm like, well, shit, does that work? What was Jordan's first step? Because look, I really want you guys with me on this. Because this just happened real time. I got here and I thought to myself, did past Jeff make a mistake? What the shit? But then I remembered Jordan's first step. So if I get to this point, is there really anything else I could do with this? Truly? No. Right? Do you guys see that? 1 plus cosine. There's nothing I could do with that. So let me come to the other side. The minute I'm on a side, I'm like, that's as far as I can go with that side. Then I go to the other side. And what was Jordan's first step? 1 over secant plus 1. What's 1 over secant?
Cosine.
Cosine. Are these equal? Check. Yay. Okay.
So I have a question.
Yes.
Do you sometimes have to check both sides, or?
Yeah, of course, like we just did. Definitely.
Okay.
Hells to the yeah. All right, that was stupid. Sorry. Hell yes. So it's not every time. This first problem we worked on one side and made it look like the other side, but sometimes, dear God, you're going to get to a point on one side and you're like, okay, I kind of like what I've done so far, but I have no idea. So then you just start with the other side. All right. And this is why I want to do several examples with you, because you go into these problems not knowing, 1, what you're allowed to do, 2, what you should expect to have to do. And then there's 3 and 4, I'm sure about. Do you guys understand what I'm saying? Like, you don't know what the flexibility is with what you're allowed to do. You don't know what you should try. Of course not, because you've never seen these freaking problems before, right? So if I do a few examples with you, I like to show you what it is that you're going to be expected to do, what it is you're allowed to do, what kind of things you should try. Okay. So can these be frustrating? Yes, they can. I'm sorry, it's just I can't change anything about that. But you know, if you get really stuck, you can always just ask me for some help. I can give you some tips. All right, let me see. Yeah, let's see. I don't know if I have enough room for this. Oh, I'm sorry. There's a chat. You don't care if we do it in terms of X and Y. Huh? Oh, if you be more specific, Bowen, you mean like, tell me what you mean exactly. I mean, if you replace,
yeah, like 1 plus secant x is like same as like 1 plus 1 over x.
Oh, well, it's actually 1 plus h over x, right? And that gets really gross really fast.
Is it not assumed that it's 1 for all these, or like it wouldn't be 1 over x and
Well,
1 over cosine? It's h over cosine.
What you're doing then is you're proving these identities only work with the unit circle. If you're assuming that the hypotenuse is 1, then any proof you do is assuming it's on the unit circle.
So for sake of verifying these, you shouldn't use 1. You should use h.
I'm saying you shouldn't even break it down to h over x.
Gotcha.
Yeah. Now, on some problems that might make it go pretty quick, but on a lot of problems, no. Plus, even if it made it work pretty well, that's not what you need help remembering. You need help remembering the identities that we're doing along the way, right? So one purpose for this is to help you memorize little identities that we use along the way. That's another kind of like ulterior motive with this. Okay. All right, so what about part C here? What's involved in part C that's different than part A and B?
The double angle
Yeah,
formula.
there's a double angle. All right. So that kind of tells me that might be something I want to try, right?
Yeah, I just did everything on the left side and it came out really easy.
Cool. What'd you do exactly?
I translated the double angle formula on the top to be 2 sine x cosine x.
All right. So remember everybody sine twice an angle, 2 sine the angle, cosine the angle. Okay.
And then I translated the double angle on the bottom to be 1 plus 2 cosine squared. I put theta, it's x minus 1.
Oh, okay. I'm sorry. I thought you were telling me what was in here. So yeah, this will be 2 cosine squared minus 1. And remember, there are 3
Cosine
options.
squared.
Sorry? Oh yeah, squared. There are 3 options for cosine 2x, correct? That's part of why it's an asshole. It gives me 3 options. Why is this the best option? Because then the ones cancel.
A lot of things cancel.
Yeah, eventually. But the nice thing is the ones cancel, which allows the other stuff to cancel. And again, if you put a different thing in here first, you're like, well, that didn't work. Well, then you would come back here and you try a different cosine 2x option. That would be a part of the process. All right, so let's see what happens here. The ones cancel, and then the 2's cancel, and then one of the cosines cancels, right? And then you're done, because that, of course, is that. All right, let me stop for a minute. I really want you guys to see how these are not impossible. If you do something and it leads you to a point where like that looks worse than it did to begin with, well then go back and try something else.
That kid sounds amped about it.
Dude, they love math. It's crazy. I might have given them a lot of candy. No, I don't know. I don't know what the hell they're doing there. They've named the tree in my yard Eleanor, so I was gonna go buy a little name tag for it somewhere. All right, guys, did that? I don't know, because that looked really gross, didn't it? Didn't it look like, how the hell am I going to show that equals that when you start? But it's double angle formulas, very much in your face. That has to be a part of this, because in order for this to have any chance to work, these can't be based on 2x while this is based on x. Does that make sense? Guys, if you ever notice a part of your identity has a different input, a different angle, you need to attack that immediately. Because the only way they could be equal is if they have the same angle at the end. All right, I have no idea. So let me stop here with this. Let me show you this other, don't worry, we're going to finish this up. Maybe not today. I want to show you this other handout, and then I think we'll call it a night. Yeah, because we're definitely there. Let me show you this one handout. Let me make sure I've got it active. This is the handout that I tried to capture the steps you take as you do these identity verification problems. Where the hell did I put it? There it is. Okay, here we go. So if you go to Canvas now, you'll see under Unit 9, you'll see this verifying trig identities. All right. At the very top is the list of things to try to do. This is what you want to have sitting next to you as you do these trigonometric identities. Now, what I'm going to do, and to be honest, what Jeff did from last semester, so thanks last semester, Jeff, is I've already got a video of all the solutions to all 15 of these. So I'll eventually put that up here, but this is like extra practice if you want it, right? But the most important part of this handout is this. Whatever you do, whichever side you work on, keep it on the other side, right? That makes sense, because the whole thing is to make the both sides look the same. Transform the more complicated side. That's normally what you try to do, is start with that. If they're both equally complicated, start with whatever one you want to do. If you get stuck on one side, let it go. Work with the other side. Substituting identities, factor something if it's factorable. If you can FOIL multiply something out, do it. If there are fractions, you might need an LCD, or you might need to multiply the top and bottom, like by the conjugate type idea that we just did. And the last resort would be make everything sine and cosine and hope to God that helps, right? If you have no idea what else to do, that's what you do at the last resort. All right, guys, that's up there if you want to use it. That is enough for tonight. So there you go. So let me know if you need to hang out. Otherwise, you are free to go running away screaming.
Thank you.
You're welcome.
Later.
See you.
Have a good night.
Sure, you too. How's everybody? You guys all right? I know
Yeah,
Dave.
You're still recording.
Oh yeah, that's right.